Welcome to the Space Weather Daily Update for the 23rd of June 2022. The purpose of this particular video is to present space weather information without spin, without loads of pseudoscience and elaborate conspiracy theories. There's too much of that going on YouTube and losing sight of the real science. You get more information on my Twitter channel. The address is here below. Each day I put out a Sun Today bulletin first thing in the morning, which describes what's been going on in the last 24 hours. In the evening, I generally put out a CME watch to show the major coronal mass ejections that have occurred during the day. If I see something during the day and I have the time, I will put out a breaking news bulletin, and that can be at any time. You obviously know where my YouTube channel is because you're watching it, but apart from these, which I hope to do every day, I do a monthly solar cycle update and also a monthly global climate update. So I hope you'll watch those as well. Already some channels that are reporting space weather here are bemoaning the fact that we don't have some of the data. There are large data gaps at the moment, and that the Solar Dynamics Observatory data is currently unavailable. They've put this down to some tremendous conspiracy theory by NASA to prevent people seeing the data. It's quite as simple as there's a power outage in Palo Alto, California. The data from SDO comes down to the Stanford University site, and a wildfire in the San Mateo Hills has cut the power to that area. So no power, no data, no conspiracy. In this series, each day I'm going to take you from the sun to the Earth and show how the various parts hang together. Here we'll start off with the sunspot number from the Solar Influences Data Center in Belgium. And you can see that the red curve here, that's the sunspots for this month, have been taking a decline for the last few days, very similar to what it did last month. At the moment, the average for the month is at 82. I imagine it'll drop to the mid-70s by the end of the month. The picture on the right shows the actual sunspots as they are currently. There's a large group in the northwest, that's the upper right. A new group has just come over the southeast limb and seems to have gained an extra spot since I last looked at it. There may be other smaller groups here, but this image is not very high resolution, and so I can't really tell what the changes have been. We can look at the H-alpha images, this one is from Mauna Loa. H-alpha is a slightly cooler line that looks slightly higher in the solar atmosphere, and you can see a number of different features when you use this. On the limb, you can see these bright areas. Those are called prominences, and they often lift off and create coronal mass ejections. On the disk, you can see dark features. Those are filaments. Actually, filaments and prominences are the same thing. When the prominence gets onto the disk, it absorbs the light from behind the prominence and appears dark. And in a couple of places here, if you look very carefully, you can see where prominence transitions from being a prominence to a filament, marked a couple of the places there. There's a very nice prominence on the northwest limb, which may erupt away in the near future. Moving higher into the solar atmosphere, we're going to look at the corona. And unfortunately, as we don't have SDO data, I've had to go to other sources to get the data. This image on the right here is from PROBA. The SWAP instrument at 174 angstroms. That's equivalent to about 1 million degrees Kelvin. This other image is from the GOES SUVI instrument, which my group built, by the way, at 194 angstroms, and also looks at 1 million degree plasma. The last image here is from the SUVI instrument at 284, and that's equivalent to about 2 million degrees Kelvin. And you can see it looks very, very different. The bright areas here correspond to the magnetic fields above strong sunspots. And you get a slight glimpse there in both the northern and southern hemisphere, just past sun center, that there are coronal holes visible in this image as well. The nice thing here is you can see both the northern and southern polar coronal holes quite clearly, and they seem quite large. That means we're not anywhere near solar maximum yet, as some people are claiming that we are. Now let's take a look at the light curve for coronal X-ray. This is from the GOES X-ray monitor. The red line here is for the 1 to 8 angstrom channel, and you can see that there have been a large number of flares. That dotted line indicates anything above that is a C flare, and I defy you to count how many C flares there are over the last 2 days. There was this one long duration event earlier this morning, which probably is associated with a coronal mass ejection. So when we get the CME data in, we will take a look and see if there was an event corresponding to that. I suspect there was. Also, if you look over the last day or two, the X-ray background has been slowly slipping lower and lower, and that tends to indicate that the sun is quieting down, at least for the time being. The next phenomenon that we want to worry about as far as space weather is concerned is the solar wind, which comes from the sun and flows throughout the solar system. There are several plots here, and we need to look at each one of them. The top one, and one of the important ones, is the so-called BZ component. That is the red line here. When that goes strongly negative, we generally will have some sort of geomagnetic storm. At the moment, it's just mildly negative and it's fluctuating a lot. That's probably not a big issue. The next important thing is the velocity, and here you can see the velocity is around about 450 kilometers per second. It was as high as 550 a couple of days ago, but it's now dropped down a bit. This fluctuates a great deal, and you can't read too much into those fluctuations. But if it goes suddenly upwards as BZ goes negative, then you're almost certainly into a geomagnetic storm. Next is the density. That's been chugging along at about 10 particles per cubic centimeter for some time now. And that's a typical value for the solar wind. The last thing here is the temperature, marked here in green. And that's varied from over 1 million degrees to about 100,000 degrees. That generally means that the solar wind has come from different sources. The over 1 million degrees generally means that it's coming from a coronal source, whereas the cooler temperatures indicate it's coming from the photosphere or the transition region. So you can identify the origin of these flows from their temperature. The solar wind flows out into interplanetary space and propagates towards Earth. And as it does so, it gets changed somewhat. The Earth is shown here to the right of the sun in a little green dot. And the color of those bars, or those spirals, indicates the speed of the solar wind and the density of the solar wind. You can see at the moment we've got a relatively low density solar wind, and that'll be that way for some time as yet. And in the bottom figure we have the speed, and that's not changing a great deal either. And you can see that there is a high-speed stream coming our way probably in about a week or so. That's that yellow part of the curve there. But again, it doesn't look as though it's going to be a major problem. It's when it starts getting red you've got to start worrying. And we can see in the streams here there are no coronal mass ejections heading our way. At least the model says there aren't. We do have two coronal holes marked here with the blue arrows. These are dark areas. They are dark because they are low density and cool, so they don't emit very much in the way of X-rays. They are the origin of very high speed solar wind, and they are moving into the western hemisphere of the sun, which is the part that's best connected to the Earth. So if they're going to affect the Earth, now will be the time that we'd start to see this. However, you notice they are both at relatively high latitudes. So there's a fair chance that these wind streams will pass above and below the Earth and not actually affect us, significantly, that is. To back that conclusion up, we can look at the magnetosphere and something called the KP index. That's a measure of how disturbed the magnetic shield of the Earth is. And at the moment, it's very quiet. It's varying between 2 and 3. That's quiet. If it gets to 4, it's technically called disturbed. Anything above 4 is a storm, and each level of KP, 5, 6, 7, 8, 9, indicates a stronger level storm. The forecast from NOAA is that it will remain quiet at least for another 2 days. From that we can estimate what happens as far as aurora are concerned, and this is a model of what the aurora will look like. And you can see it's fairly weak and at very high latitudes, so there's not going to be very much in the way of auroral activity, at least until the solar wind changes quite significantly. Now, I've told you what the space weather effects are, but one of the things that I get very annoyed about are these channels here that pretend that space weather does far more things, far more exciting things as far as they're concerned. What solar activity does not do does not change our weather patterns, causing floods, droughts, wildfires, hurricanes, heat waves, or polar vortices. It does not affect the strength of the Earth's magnetic field or cause the magnetic pole to shift, as some people claim. And there are those charlatans that continue to believe that they can forecast earthquakes and volcanic eruptions from solar activity. That is absolute nonsense. So don't be taken in by those folks, particularly if they're asking you for money. So this is my first attempt at doing this daily space weather update. As I do more of these, I'll add more and more things in, but only if they're relevant to space weather here on Earth. So until next time, stay safe and goodbye.